The Laws of Reality, by Alessandro Pulverenti. The first thing we need to clarify is the difference between scientific laws and those of reality. Scientific laws are based on simple models that overlook the complexity of reality. Sometimes it's just a matter of approximation, because some variables are ignored. For example, as in the case of the equation of state of ideal gases, the following are neglected: the volume of the molecules, their polarity and more. Other times the model used is really wrong, which assumes that the system behaves in a certain way, while in reality something else happens. The laws of reality take into account the complexity of reality, and therefore, the equations that describe them are often more complex but are also more precise. This means that a sort of ranking of laws is created according to their precision. A law is of reality if 1. Its model describes what actually happens, 2. Provides a mathematical equation that considers the significant variables and which allows the precise quantitative calculation of the quantities involved. In summary, we could say that everything that is part of the universe is real, both matter and energy. However, while matter and energy respect the laws of reality, energy can project virtual worlds that are not bound by such laws. A dream and a projection of the mind's energy, it does not respect the laws of reality, but what the mind wants. A virtual world is a projection of the energy flowing in a computer. It too does not respect the laws of reality, but the laws that the software defines. A law of reality defines how what is present in our universe behaves when it interacts with spacetime or with other things present therein. Here I will not describe in detail how I arrived at these laws, nor the numerous mathematical steps that were required. The law will be presented in its simplest mathematical formulation, as it is possible to describe these laws with different formulas and quantities. The individual factors that are part of the law will be explained. For those who think that the current scientific laws are the correct ones, I will give examples in which it will be seen that the laws of reality describe in a more precise way what happens from a qualitative and quantitative point of view. The ultimate judge of the goodness of these laws is given by the experimental tests. The first law of reality defines how electromagnetic radiation, composed of photons, loses energy when it travels through spacetime. Just as a car consumes fuel when traveling through space, light also consumes energy when it travels through space. Every time light travels a space equal to its wavelength, it emits a quantum of energy. This energy quantum will later be discovered to be a graviton. With each graviton emitted, the energy of the light decreases and consequently the wavelength increases. Thus, knowing how much energy a certain electromagnetic radiation, light, had when it was emitted, and knowing the energy that is observed upon arrival, you can calculate the distance traveled. From this it is possible to calculate the distance to astronomical objects such as galaxies billions of light-years away. Electromagnetic radiation has some interesting properties. Regardless of their frequency, they emit the same percentage of energy for the same distance traveled. The sum of the space covered by the energons that make up the photons is equal to the wavelength of the graviton. The photon converts an energon into a graviton and emits it. From the first law of reality it is possible to make some predictions. 1. The background radiation arriving from space was emitted at a distance of 409 billion light-years. It follows that the universe is much bigger and older than we thought. 2. Being that visible light, traveling through huge spaces, moves towards longer wavelengths not visible to the naked eye, it follows that no visible light arrives from distances greater than a certain distance. This explains Olber's paradox, who wondered why space was black and not all illuminated by an enormous amount of galaxies. 3. Light can travel a maximum of 1063 billion light-years before running out completely. From this it follows that no information can reach us directly from greater distances. From the first law of reality it is possible to understand how some things work in the universe. First, there was no Big Bang. The background radiation could come from the edge of the universe. Second, the universe is not expanding, but it is static. The redshift is not caused by the expansion of the universe, but by the fact that light loses energy as it travels through space. Therefore, there is no dark energy. Third, Hubble's law is incorrect. The true law describing redshift is the first law of reality. This allows us to explain why the most distant galaxies are located at a much shorter distance than what was calculated with Hubble's law. A law is such if it is possible to define a way to refute it, that is, prove that it is false. To disprove Hubble's law, it is sufficient that one of the above conditions is satisfied. 1. Dark energy does not exist. 2. There are galaxies that are older than the estimated age of the universe. 3. The most distant galaxies cannot form so quickly after the Big Bang. 4. The expansion of the universe proceeds at speeds greater than that of light. 5. The redshift due to the expansion violates the principle of conservation of energy. Instead, to demonstrate that the first law of reality is false, one of the above conditions must be satisfied. 1. It must be demonstrated that there are no particles smaller than neutrinos. 2. There must be no galaxies older than 14 billion years. 3. There must be no galaxies more distant than 50 billion light-years. The new observations made with the James Webb Space Telescope show that the first law of reality is the one that correctly explains the distance of the stars. Instead, to understand why a static universe doesn't collapse into a black hole, we need the second law of reality. Second law of reality. The model that is described by the second law of reality defines the force of gravity as mediated by gravitons. Very small particles emitted in all directions by mass and energy. The mathematical equation that describes this law is composed of numerous factors, which derive from the properties of gravitons, and therefore goal of the force of gravity. The first factor indicates that gravitons move at the speed of light and that they are only minimally absorbed by the masses they encounter, i.e., the mass appears to be semi-transparent to gravitons. These gravitons are so small that if a proton were blown up to the size of the Sun, a single graviton would be as large as a human cell. Although the total energy transported is very small, the amount of gravitons emitted is truly enormous. A single proton emits 200 trillion billions per second. The second factor represents the surface area of a sphere of radius equal to the distance between the two masses. The gravitons are emitted in all directions, therefore, the quantity that reaches another mass is inversely proportional to the surface of the sphere, but directly proportional to the other mass, as the more massive the mass that receives the gravitons, the more it will absorb. Third factor, mass times phi representing self-absorption. Bodies emit gravitons which are absorbed by other masses, but a part of them is absorbed by the same mass which emits them. In fact, an asteroid made up of many shavings emits gravitons which are partly absorbed by these, and cause the asteroid to remain aggregated as a single body. For bodies as large as a planet, self-absorption is negligible, only one graviton is absorbed for every million emitted. The masses emit gravitons, but a small part are absorbed by the same masses that emit them, reducing the force of attraction. The consequences of self-absorption are: the ratio between gravitational and inertial mass is not unitary, they are not the same thing. Some might object, saying that the equivalence between gravitational mass and inertial mass has been verified up to the 12th decimal place, but from the second law of reality we know that this difference is noticeable to the 17th decimal place. It is 100,000 times lower than what could be tested in practice. Einstein's equivalence principle is therefore invalid. Given a spherical body, the force of gravity is directly proportional to the mass and inversely proportional to the square of the radius. Since the mass of a sphere increases with the cube of the radius, it follows that radius cubed over radius squared, it follows that the force of gravity is linearly proportional to the radius. Instead, the mass of a disk is proportional to the square of the radius, therefore, the force of gravity remains constant throughout the disk. Considering in a spiral galaxy, the orbital velocity of the stars on the disk is rightly constant. Kepler's laws cannot be applied to spiral galaxies, as they are valid only for spherical bodies, while such galaxies are disks with only a spherical galactic center. As a result, the orbital velocity of the stars increases as long as we are inside the spherical galactic center, while then it decreases at the beginning of the disk and then remains approximately constant throughout the disk. Consequently, the dark matter hypothesized by science does not exist. Kepler's laws become valid again, very far from the galaxy, when it is perceived as almost punctiform. Fourth factor, dependent on the relative speed, i.e. on the radial speed between the bodies. The bodies that approach each other absorb a greater number of gravitons and therefore the force of gravity will be greater than that calculated with scientific theories. This factor becomes important when one of the two bodies travels along a very eccentric ellipse or even a hyperbola. Examples highlighting the consequences of the relative speed factor are: 1. The precession of Mercury's orbit, which was not exactly explainable even with Einstein's general relativity, while now it can be calculated precisely. 2. The orbit of the interstellar asteroid Oumuamua, which was anomalous, because it did not follow Newton's law or Einstein's general relativity, is now consistent with the new law of reality. Further consequences of the airspeed factor are: double curvature, with respect to Newton's law, when light passes close to a large mass. The factor is equal to 2 and doubles the force of gravity that the light feels. From this it follows that this law of reality explains in a more complete way what general relativity explained in an absurd way. It follows that Einstein's model of general relativity is wrong. Fifth factor, due to the oscillation of gravitons. Gravitons are oscillating particles, like neutrinos. After traveling a distance equal to their wavelength, they transform back into energons, reversing their strength. This means that the force of gravity does not have an infinite range, but acts up to a maximum of 14 billion light-years. Beyond this distance it becomes repulsive and prevents the universe from collapsing on itself. Indeed, the oscillating functions are those which may not diverge to infinity, making sure that the universe does not take a clear direction, both towards expansion and towards implosion. It follows that dark energy does not exist. From the application of the second law of reality, it is possible to understand how the latter behaves in extreme cases. Are black holes really what has been imagined up to now, or do they have different characteristics, which appear to be more consistent with observations? Let's apply the second law of reality more carefully to black holes, to see what it can tell us about these astronomical objects. 1. The mass of the black hole is different from that calculated using its gravitational force. Self-absorption becomes significant, so the mass is greater than the force of gravity exerted by the black hole. 2. A ray of light emitted by a black hole, due to the relative speed factor, should not feel the force of gravity, since gravitons also move at the speed of light, and therefore could not be absorbed. In reality, the bodies are not punctiform and, for extended bodies, we must also consider the gravitons coming from the side. Clearly they are only influential for distances of a few multiples of the radius of the body. The farther you go, the less lateral gravitons there are. These gravitons absorbed in the first part of the trajectory reduce the energy of the light beam and therefore increase the wavelength. Moral of the story: a ray of light can always escape from a black hole, which is therefore not black. In fact, black holes, when they absorb the gas around them, emit a lot of radiation, and also neighboring gases. Third, the force of gravity increases linearly with the radius in uniform spherical bodies, as the mass increases with the cube of the radius, while gravity decreases with the inverse of the square. At the center of a black hole, the force of gravity is not very strong, as current science says. At the center there is no singularity. On the contrary, the force of gravity at the center of each mass is always equal to 0. Fourth, because of the transparency of mass to gravitational force, no body, however compact as atomic nuclei, can absorb enough gravitons to overcome the nuclear forces. Therefore, microscopic black holes cannot exist even for an instant. Fifth, thus, the most compact astronomical object that can exist is a neutron star. Sixth, even the most powerful blazars are no more compact than a neutron star. In fact, they are huge in size. Seventh, absolute time flows regularly, as time is a property of space. Eighth, the proper time of the object attracted by the black hole is affected only by its speed relative to the speed of light. There are other laws of reality, which will be shown in the next videos, but it is already possible to begin to understand how the universe works. By applying the first two laws of reality, it is possible to find a model that seems to correctly describe the fundamental structure of the universe. That model will be extended before the end of this video. For science, the universe is commonly defined as the complex that encompasses all space and what it contains, i.e. matter and energy. The definition can fit only if the concepts of space, energy and matter are well defined. Let's begin by giving a scientific definition of spacetime. In physics, spacetime, or chronotope, is the four-dimensional structure of the universe. In fact, the space we live in has a three-dimensional structure. Time is a property of space, i.e. its refresh rate. The neural model is what represents spacetime in the laws of reality. Space exists. It has a rigid three-dimensional structure. It is discrete, composed of cells. Each cell is connected in the three axes and in the two directions. There is no absolute reference system. Each cell has a dimension of approximately 10 to the minus 39 meters. The fundamental particles are positioned in the cells of space, relative position. It is wrong to say that a particle has a position, as that position is not part of the particle, while it is more correct to say that the particle is in a cell or position. Cells are relative in the sense that they are not numbered or sorted. There is no such thing as cell number 1 or 2. Time is the changing of space. Time is discrete, made up of distinct instants. Time is absolute, it passes everywhere in the universe at the same speed. An instant is the time needed to move the contents of a space cell to the next cell. An instant represents the present and lasts about 10 to minus 48 seconds. This means that light travels 10 to 48 cells per second. From the absolute time derives the proper time, which is influenced by the speed of the object. According to official science, energy is that physical quantity which measures the capacity of a body or a physical system to do work. This definition does not allow us to understand whether a body has energy, and therefore that capacity, or not. The laws of reality take into account the fact that energy is composed of very small indestructible particles, the energitons. From this definition we understand why there is a principle of conservation of energy. Energitons are the particles that transmit energy. Such particles, they are shieldable, are emitted by charged particles. They have a range of 1,063 billion light-years. They are particles that represent energy and transmit it in the same direction of motion. They oscillate from energiton to graviton states. They are indestructible. Principle of conservation of energy. Each particle carries 1.47 by 10 to minus 51 joules. From the characteristics of the neural model of the universe, is it possible to decide whether our universe is real or simulated? In reality, our universe is real in that our reality is where we are. The question tries to be deeper and tries to understand if, what is real for us, for another entity outside the universe, can it be only a simulation that can be stopped or modified? Or, we wonder if we are really inside this universe, or are we outside and see the simulation of this universe and interact with our body here, as well as a video game player makes his avatar move. To try to understand if we are in a simulated universe, we can first try to solve a similar, but much simpler problem. How do we know if we are dreaming or awake? We need to force the system, that is our mind, beyond its capabilities. A computer system generally has two types of capabilities that can be forced, and they are the amount of memory and the speed with which it processes them. Our dreams are projections of our mind. If we stretch our memory and the speed of the mind to process information beyond its capabilities, we find that we are dreaming. A simple way is as follows. The person who is dreaming must imagine taking a book that she does not know and opening it to a random page and reading many of the lines therein, trying to see the lines of text that he is reading. Our brain is unable to invent the content, project the text onto the pages of the book, processing limit, and in the meantime, memorize the content of many lines of text, memory limit. Therefore, if in the dream we are unable to do this, we understand that we are dreaming. Now that we know how to understand if a universe is simulated, let's try to see if the neural model of the universe that we have adopted can be simulated or not. If the universe is simulated, there must be limits imposed by memory and limits imposed by processing speed. As we have already said, the space of our universe is discrete and composed of cells of finite size, therefore, the number of cells of space to store is limited. We have run into the memory limit. Let's see if there is also the processing limit. The contents of the cells throughout the space of the universe are updated at a fixed rate, which is the speed of light. Cell contents cannot be swapped at a faster rate. And we met the processing limit as well. Trying to solve this puzzle led me to extend the properties of the neural model by considering the possibility of parallel universes. By analyzing the neural model of the universe and trying to solve the enigma of the simulated universe, we can make some considerations. If we are in a simulation, it means that there is another parallel universe that is simulating us. If our universe is composed of a 3D space and the energy contained therein, there must be something that defines the properties of the space cells, the actions that must be triggered when the particles interact, etc. This, in computer programming, is handled by classes that represent both the data that is exchanged, the properties of the object and the actions. If this leads us even closer to the idea that our universe is simulated, there is new information that makes us understand that things are not so simple. Particle accelerators collide very high-energy particles. From these collisions, new unstable particles are born which decay rapidly and restore the energy of the original particles. In space cells, when so much energy is concentrated in one area, we didn't know how those cells behaved. Now we understand that these space cells are composed of several levels, fourth spatial dimension. Each level enjoys the principle of conservation of energy. This means that, if some energy rises to the higher level, there must be some energy that falls to the lower level. During the collision of high-energy particles, it is possible that the energy of the collision rises to the higher level and that some particles that exist in that level fall to the lower level. These particles are unstable because they tend to go back to their level, causing the equivalent energy to go down again. The parallel universe present at the upper level could have matter composed of atoms like ours, only they are much more massive. Our electrons are 200 times less massive than the muons, which should be the electrons at the upper level. If so, we know that we can communicate directly with two parallel universes. In fact, if parallel universes exist, they must necessarily be communicating, otherwise it is as if they did not exist. Positive electric charges are also referred to as sources of the electric field, while negative charges are considered sinks. Are the charges communicating with a parallel universe from which they take and pour out the particles of the electric field? Small digression to be able to answer a question that we have been asking ourselves since time immemorial. Is there destiny? The laws of reality tell us that the probabilistic theories of quantum mechanics can actually be described with precision by knowing the elementary particles that make up the fields. This would lead us to say that, knowing the properties of all the elementary particles present in the universe, it would be possible, at least theoretically, to know the future and therefore the destiny of all. From the latest findings, we can definitively answer that destiny does not exist. It is not possible to predict the future with extreme certainty, even knowing the properties of all the particles in our universe. This is because our universe continuously exchanges particles with parallel universes, and since we cannot know everything there is in all parallel universes, it follows that neither we, nor any alien being or God, will ever be able to know our future with absolute certainty, because the content of all parallel universes should be known, and since they are all communicating, just trying to know the future would change it. This process it is called recursive, because with every attempt to predict the future it follows that it changes. Being that the clues lead us to hypothesize the presence of parallel universes, it is normal to wonder if the sightings that have taken place on Earth are by extraterrestrials or are aliens. In this video we will consider extraterrestrials as inhabitants of other planets, while for aliens we will consider extra-dimensional visitors, i.e. coming from parallel universes. Let's see if our information can lead us towards one or the other solution. Considering the hypothesis of extraterrestrials, we must consider that even the neural model of space has the speed of light as its maximum limit, but for linear and continuous displacements. However, this model allows stargates to be opened which allow passage between two distant places in the universe. Space cells, in addition to connecting with adjacent cells, can also connect with cells that are far away. How this can happen is still under study. If, on the other hand, they are aliens, they must still respect the laws of this universe. If they come from the higher adjacent universe, they should have a significantly higher energy content, and their appearance in our universe would have to be accompanied by a kind of explosion in order to transfer a considerable amount of energy to the neighboring universe. If the hypothesis of extraterrestrial beings who come to visit us, according to Occam's razor, are more probable, as there is no need to confirm the presence of extra dimensions and parallel universes, then we have to understand how UFOs can travel in our skies without having an inertial mass that breaks their accelerations. As we have already discovered, inertial mass is a very different thing from gravitational mass. While for the other sizes I have given a precise definition of what they are made, as for mass, there's still nothing certain about what it is. We know that there is the moment of inertia caused by the rapid rotation of an object. It means that the faster the object rotates, the greater the inertia of the object in changing the inclination of its axis, while there is no additional inertia in translating it. The inertial mass is likely to be due to the movement of elementary particles causing the mass to inertia in all directions. It is likely that by aligning the motion of such particles, it is possible to deactivate the inertial mass. Clearly, this is only a hypothesis to be explored. Any extraterrestrials are likely to know how to disable inertial mass, and this allows them to reach great speeds with enormous accelerations. The first two laws of reality change all of astronomy. The universe works completely differently than they thought. Now we know that 1. Scientific laws do not correctly describe reality. 2. Dark energy does not exist. 3. Dark matter does not exist. 4. The universe is stationary and is bigger and older than they thought. 5. Energy, space and time now have a precise definition. 6. The force of gravity is mediated by gravitons. The properties of these particles determine the characteristics of this force. 7. From the properties of the force of gravity, the characteristics of black holes can be deduced. 8. Inertial mass and gravitational mass are different. 9. It is probable that there is a fourth dimension in parallel universes. The new laws of reality and the new model of space lead us to new questions. 1. We need to understand how to activate and deactivate the inertia of mass. It would allow interplanetary travel. 2. The space model described allows the opening of stargates, distance connections. We need to find out how this can be done. It would allow interstellar and intergalactic travel. 3. Our universe is not the only one, but it seems that the parallel universes are communicating. Discovering easier ways to get from one to the other would allow for interuniversal travel. The laws of reality have been discovered to try to solve the problems of the third millennium. In 2022, the world population reached 8 billion people and looks set to grow further. The lack of resources leads people to war. The extraction of resources devastates the environment and their consumption generates further pollution. Furthermore, any dangers from space make us understand that we need to find out how to go to other planets and how to make the most of the new discoveries. Thank you for listening, and if you are interested in the video, leave a like to improve the positioning of the video. If you are interested in the next videos on the laws of reality, subscribe. See you in the next video.